video, we're going to talk about some applications of partial fraction decomposition and the role they play in analysis of its graph. Now, generally what we're going to be doing, we're going to be finding the partial fraction decomposition of the graph by doing a couple different methods first. So, in example 6 here, it says compare the graph of the rational function with the graphs of the terms in its partial fraction decomposition. Now, in order to do that, because the leading term in the numerator and denominator have the same degree, in this case squared, we have to go back, we have to actually do polynomial log division first. So we'll do that. Now, x squared goes into 2x squared twice. So I have 2x squared plus 0x minus 8. So we're going to switch all the signs down here. So that goes away. We'll have an x minus 6. So I can really rewrite this as 2 plus x minus 6 over x squared minus 4. Now, in the past, we'd be okay with just leaving it like that. But now that we know some partial fraction decomposition, we'll have to make that fraction a little bit nicer to look at. So the way we do that then, the fraction that we want to make smaller then is this fraction. So that'll be a over x plus 2 plus b over x minus 2, because as you can see, x squared minus 4 will simplify to x plus 2x minus 2. So really what we'll have on x minus 6 is equal to a times x minus 2 plus b times x plus 2. Simplifying further, we'll notice that ax minus 2a plus bx plus 2b will be that's going to be simplified there. Simplifying further, putting in our parentheses, we have this, which means a plus b will equal 1, because that's the number in front of x, and negative 2a plus 2b will equal negative 6. Now we can do some little simplifications here where we have negative a plus b equals negative 3 by dividing everything by 2. Then we can move this equation, actually, we can move it over here, and then add down. So we have 2b is equal to negative 2, which means b will equal negative 1. Because b equals negative 1 then, we actually put it into our first equation. A minus 1 equals 1, which means a will equal 2. So here's our a value, here's our b value. A is 2, b is negative 1. Which means this function here will be 2 plus 2 over x plus 2 plus a negative 1 over x minus 2. Now we can check this again in our calculators as follows. So you're going to put 2x squared plus x minus 14 divided by x squared minus 4. Make that bold there. 2 plus 2 divided by x plus 2 plus a negative 1 divided by x minus 2. As you can see, the bolded graph goes exactly over our original graph, so that tells you that the partial fraction and the original function are the exact same. Now, what we can see here, you can see from the graph that there's going to be vertical asymptotes at negative 2 and at positive 2, so x equals positive or negative 2. You can also see that from our denominators here. That tells you that there's going to be vertical asymptotes there. You can see that from the original function. Now you can also see from our horizontal asymptote test, or leading term test, that 2x squared divided by x squared is 2. So this positive 2 at the beginning actually tells you that there's going to be a horizontal asymptote at y equals 2, which you can see. So that's how you compare the graphs. Looking at example B, we're going to do pretty much the same thing. The leading terms both have the same degree, so we're going to do some polynomial log division here. X squared goes into 2x squared twice. So 2x squared plus 0x minus 2. We're going to change our signs. That goes away. We'll have x plus 5. So you could really write this as 2 plus x plus 5 over x squared minus 1. So really the one we're going to be changing is x plus 5 over x squared minus 1. And you can really write this as a over x plus 1 plus b over x minus 1. Now, if we multiply everything by x squared minus 1, you'll see that we'll be left with x plus 5 equals a times x minus 1 plus b times x plus 1. Doing some distributing, we have ax minus a plus bx plus b, which means we'll have a plus b x and negative a plus b here. Now that tells you then that a plus b will equal 1. And also, negative a plus b will equal 5. If we add these down, the a's will go away. 2b will equal 6. B will equal 3. Now, since a plus b equals 1, and b is 3, that means a will equal negative 2. Now, putting this back into our partial fraction decomposition, a is negative 2, b is 3. Again, you should be able to see that we're going to have vertical asymptotes at x equals plus or minus 1. We'll have a horizontal asymptote at y equals 2. So when you put that function into your calculator, so this would be a minus 2. As you can see, the graphs are exactly the same, so therefore we do have the correct partial fraction decomposition, which means the vertical asymptotes and horizontal asymptotes are the same. The big thing that you need to remember with this video, in this example, number 6, if the degree of the numerator is the same as the degree of the denominator, you must do polynomial log division before you start the partial fraction decomposition. Partial fractions only work if the degree of the numerator is less than the degree of the denominator. That will do it for 7.4. If you have any questions, please come and ask.